If you looked around me in the air right now, what would you see? Probably nothing. But as I speak, all around me are nitrogen molecules, making up about 78% of the air we breathe. And it's not just in our air, but everywhere. In our water, our soil, and even the plants we eat, making it Earth's most abundant element. How do plants get nitrogen from the air anyway?
Hi, my name is Ava Brantley, and I'm here today to talk about nitrogen fixation. First of all, why is nitrogen important to plants? For plants, nitrogen is needed to synthesize proteins and chlorophyll, supporting plant growth and photosynthesis. Without nitrogen, plants would be unable to grow. However, because atmospheric nitrogen bonds are too strong for plants to break down, nitrogen must be turned into ammonia, or NH3, a form plants can use. But how? Through the nitrogen fixation process, of course. This process, called nitrogen fixation, is an important part of the nitrogen cycle, a cycle that describes the movement of nitrogen through the air, soil, plants, and animals. There are many steps to this cycle, but for this video, we will just focus on the first step, involving nitrogen fixation. Here is a snap bean plant, belonging to the legume family, a family consisting of beans, peas, and clover. In the early 1900s, Martinus Beijerinck, a Dutch microbiologist, discovered that legumes are the only type of plants who have a symbiotic relationship with rhizobium bacteria in the soil, allowing them to transform atmospheric nitrogen into a usable form, ammonia, NH3. This is why on my family's farm, we plant legumes before other crops to increase nitrogen levels in the soil. So how exactly does nitrogen fixation happen? When legumes are first planted, they send out little hairs from their roots and release flavonoids to attract rhizobium bacteria. This causes the bacteria to produce nod factors, which is a chemical message initiating the rebuilding of root nodules, a sort of protective house for this bacteria to convert nitrogen in. Connective tissues surround the bacteria and root, allowing nutrients and nitrogen to pass back and forth between the legume and bacteria. Now, as N2 from the air makes its way into the soil, it encounters rhizobium bacteria in the legume's roots. Through this encounter, rhizobium bacteria use an enzyme called nitrogenesis, which allows the bacteria to combine hydrogen and nitrogen to create ammonia, or NH3 from atmospheric nitrogen. Through this relationship, both the legume and bacteria benefit. The legume gets the transformed nitrogen, now ammonia or NH3, and the bacteria gets the sugar from the legume. One cool thing is that when the root nodules are gray or white, we know nitrogen fixation hasn't occurred. However, when the root nodules turn pink from the presence of leg hemoglobin, which moves oxygen out of the nodule, we know that nitrogen fixation has occurred. Here's an example of a pink legume root nodule.
The next time someone asks you what's so special about beans, you have an answer: nitrogen fixation.
Thank you for watching this video, and I hope you enjoyed learning something new.